Hi roboticists, in this video we are going to create our MoveIt2 configuration package for our custom robot designed in ROS2 with the ROS2 controllers. We will go through all the MoveIt2 installation in binary, and we are going to download from source the MoveIt2 resources tutorials, and then we are going to use the MoveIt2 Setup Assistant wizard for our custom robots, and then we are going to solve some problem that most likely you have faced if you have used the standard wizard and demo launch file that has been automatically generated from the MoveIt wizard. Okay, so stay till the end of this video, because I'm gonna reveal you the exact behavior and a step-by-step procedure to make your robots run in a correct simulation in Gazebo in a ROS2 environment. And this procedure is I would say different from the one that you have seen in my previous video in ROS1. Okay, so let's get started. Okay, so before to start, make sure to subscribe to the channel and hit the notification bell if you want to miss up the opportunity to become a robotics software engineer. In order to design and deploy a robotic application for your project, if you are a hobbyist, or for the company you are working with and master your career. Okay, without further ado, let's get in the topic of today. So, first of all, I want to present this workspace. So basically here I have this 6-arm package. I have the industrial environment in Gazebo, and then here some trials for MoveIt configuration. But this chakra file is the one that is the most important, and basically it's describe a 6-axis robots, and here you're gonna see the ROS2 control tag using this hardware interface that is gonna be the one that allows you to simulate your robots in Gazebo. Okay, and then I have created this launch file that allows you to spawn your robots in Gazebo with the controllers. Then I have created a joint publisher C++ file in order to move to joins. Okay, so first of all, let's open a new terminal and let's run this launch file that I have just shown you. So now let's launch this launch file that is spawning our robot that has been described with this URDF with this controller in a Gazebo with a custom environment. So ROS2, launch the name of the package, and then the name of the launch file. So here we have our robots that is stands, and there's going to be also RVs. For the moment we are not interested in RVs, but the fact that is stands it means that the controllers are spawned correctly. So if we open a new terminal and we run the joint publisher that I just shown you, ROS2 run the name of the package that is going to be 6-arm and then the joint publisher node, you can see that we have only two joints that are moving. Okay, so this, and here you can see that RVs is moving accordingly. Okay. This is the first things. So basically with this setup, you can run into a forward kinematics problem. So you're going to set up the joint angle, and then the end effector, in particular this custom gripper, will reach the position that will be the result of the value of the 6 joints. But you might know that in a robotic application, the most interesting part is the inverse kinematics, where you're going to set up a certain position with respect of the base link, for example, and then there will be some inverse kinematics algorithm that will find the joint position to allow the end effector to reach a certain position. Okay, and the best tool to use this, or better, the best framework to use this, to do this, is MoveIt. And if we run in ROS2, then we have to run MoveIt2, and then for doing that, we are gonna install MoveIt2 in with respect of the ROS2 distribution, and in this case it's going to be humble. Okay, so let's close everything here, and now let's install MoveIt in binary first. So go in this website, and so MoveIt, install MoveIt, there we go, and then you need to select the ROS2 distribution. In my case, it's going to be humble. You just need to copy and paste this. Okay, I can do it again, but it will change nothing because I have already done it. So make sure to open a new terminal, and let's run this line here. Okay, so then an important thing, since that we wanted to see the behavior of a very structured package as the one that MoveIt2 official repository provide, in particular the Panda robots, I really suggest you to download from the source the official repository of the MoveIt resources tutorial. So if you go to this web page, what you need to do is exactly to follow exactly the same this procedure. Okay, I have already done it. I'm not going to do it again because it's gonna take for the installation of the package a lot of space and 20 minutes, I will say. Then I'm gonna tell you exactly what you need to do. So open a new terminal. So let's clear this up, and then you need to just copy and paste this. So you need to source your environment, then you need to install Python 3 ROSDEB. I think that if you have already run into a simulation in ROS2, you should have already done it. Then you need to just copy and paste this. You need to install Concol common extension, and if you have followed a standard procedure of ROS2 installation, you haven't done it yet. So you're gonna need to install mixing, and then you copy and paste this, and then you need to install a VCS tool. Then you need to create a workspace for MoveIt. I have already done it. I have just called this workspace underscore MoveIt, but is exactly the same. Okay. So then you need to go inside the src folder and then clone the official repository. Make sure to put the branch humble here. Okay. Then you need to download the source code. There we go. And then you need to start to build your Concon workspace. So just copy this and paste in your terminal, then move to the workspace MoveIt, and then you need to run this. But I will suggest you to run another command. So if you move, let's say that we are here, and if we move to cd workspace MoveIt, okay, I will suggest you to paste this. So it's concon bin mixin release, and then you need to do executor sequential. This is not written here. This is a good practice because since that you are going to use all the resources of your computer, it's a good practice to build the package sequentially. There's nothing to understand too much, but I will suggest you to do it. Otherwise, you might face some problem. Okay. So the installation, after that you run this line, it will take around about 20 minutes. Okay, so let's say that you have already done this. And then you need to source this one. So now we can do it step by step together. Of course, here I have MoveIt. There we go. Okay. Then what you can do is go to next, and then we are going to copy and paste this line here. So we want to launch the MoveIt2 tutorials demo.launch.py, and then we need to set up as RVS configuration the Panda MoveIt configuration demo. So if we run here, we have an empty word, let's say here, and then what you need to do is to add the motion planning here. Then you can see that our Panda robot is spawning here. And then let's change to a Panda arm. Then let's move your end effector of the Panda wherever you want, and then let's go to plan and execute, and then you can see that the simulated robot, the Panda one, the one that is available in the MoveIt official repository, then is gonna move. Okay, so feel free also to use the other planning group, and then there we go. Okay, so we have seen a very good example of an official tutorial, where you can see that if in MoveIt2 we ask the end effector to go in another position, then you will see that the robot will go and will follow a certain trajectory, and this trajectory has been calculated automatically from the motion planning plugin provided by this MoveIt framework. Okay, but This is not interesting for us because probably most likely you're gonna have another kind of robot, whatever is gonna be a custom robot or a universal robot or whatever it is. So most likely the good procedure is to let's say create your custom MoveIt configuration package. And if you wanted to do it, you will need to use the MoveIt setup assistant. So let's open a new terminal. And since that you have downloaded from binary the MoveIt framework, you just need to type ROS2, then launch, the name of the package that is going to be MoveIt setup assistant, and then the name of the file is going to be the setup assistant launch. There we go. So I have already done a video in ROS1 for MoveIt Setup Assistant wizard, but this is MoveIt2. Okay, so it's pretty much the same, but with some difference that we're gonna see in a while. So let's first create a new MoveIt configuration package. And we are gonna use so I'm gonna go here and I'm gonna use the not this one, the chakra file that we have seen here, that is gonna be cobot trajectory control URDF chakra. There we go. So if we load the file, we have our robots. Okay. Then self-collision. There's going to be a lot of tutorial in YouTube for running this configuration package wizard. So in our case, we don't have a virtual joint. We need to add some group. Let's call it arm. Let's use this kinematic solver. Then add the joint. In our case is gonna be this one. Save, then we add another group that is gonna be the gripper. Here we don't need the kinematic solver. We add a joint. The joint is gonna be the right one because in my case I have the finger left joint that is mimic the behavior of the finger right joint. It's very common, this type of configuration. And then we need to set up the link of our gripper. Then let's set up some pose. It's very easy. So this is going to be the 0 position. Then let's set up a home position. Let's have it like this. Okay, then let's add also for the gripper position open and then the close position. There we go. So the end effector, let's add a new one, and effector. Then the end effector group is going to be the gripper and it's attached to tool 0. So this is a new thing with respect of MoveIt Setup Assistant in ROS1. So here is reading the ROS2 control. Then we say that we have a command interface, the position, and a state interface, position and velocity. If you want to have more detail in that, check check out the link in the description down below, where there's going to be more detailed lessons and a masterclass for running into a real robot application with the controller, where I'm going to explain everything regarding also the ROS2 controls, okay, and the controller manager. So here there's going to be the controller that is associated with MoveIt, and here an important thing. So this is the type of controller that has been automatically generated. An important thing is that this name here has to be the same of the configuration folder. So here we have named the controller arm trajectory controller and a gripper action controller, okay, with this different type here. So here we need to change arm trajectory controller, and this is of type joint trajectory controllers. Okay, I don't want to go too much into the details. Again, if you want to go into the detail, check out the masterclass. So then gripper action controller, and then we have a type position controllers, gripper action controllers. So in this case we are gonna passing to the controller an action rather than a topic. And then you need to do the same exercise here, so make sure to make this name trajectory. There we go. And here gripper action controller, and the controller type is going to be a gripper command. This is a gripper command action type. Okay, so arm trajectory controller, gripper action controller, and this is the same here. Okay, so the name of the controller and the time of the type of the controller has to be exactly the same. This is a crucial thing. Perception, we can skip this up because we don't have a camera. In the masterclass, we are gonna have a camera, and we are gonna do exercise like a pick and place using the camera as a perception. Launch file, you don't need to add anything, and in the author information, let's put your name. Okay, now you need to select the name. So we are here, so we can add another folder, and this is gonna be ARM configuration ARM, sorry, MoveIt config. Okay. So let's open, and these are all the file that will be automatically generated. Okay, so let's generate the package. So skip this warning, it's not important for us, and then we can close it. There we go. So here we have our brand new MoveIt configuration package automatically generated. So let's build the package. There we go, it's done. And then let's have a look at what is here. So we have this configuration file and this launch file. Let's run right away demo launch file and see what's happened. Okay, so you need to source the environment. ROS then launch. The name of the package that is going to be arm MoveIt config and demo um, launch.py. Let's see what's happened. Okay, there we go. There's gonna be our robots, okay, spawned. We have a configuration similar of what we have found it in the Panda. But what's happened if we move our end effector in another position? So let's plan and execute. Here we can see that is planning, but the execution is failed. Okay, and this is a critical part that a lot of novice, I will say, in ROS2 and MoveIt2 is facing. The main problem of MoveIt2 wizard, and in particular the demo launch file, is that in ROS1, under the hood, all the fake controllers were spawned. Okay, and then you can simulate your robots, your trajectory, even if you didn't have any controller, because as default was loaded the fake controller. In this particular case, if you're gonna see the launch file of your ARM MoveIt configuration package, is gonna be very easy. Okay, and then basically in ROS2 and in particular in MoveIt2, what you need to do is to spawn explicitly your controllers, and in particular your controller manager. Okay, so what we are, and in fact, if we see the log error, it says that they cannot contact the service controller manager. Okay, and in fact, if we open a new terminal and we run a ROS2 node list, we don't see the controller manager, and this is not good because it meaning that you don't have the controllers. Okay, so let's close this and let's solve the problem. Okay, so the first things that you need to do is a good practice. If there's something that worked and now something that didn't work, what I will do is to make a comparison between the package that worked and the package that didn't. Okay, so let's go inside in our package that worked. So MoveIt resources, Panda, and MoveIt config, and then let's have a look in this config folder. As you can see here, there's going to be a lot of configuration file rather than here. So I don't want to go into detail, so just trust me. So just copy this like kinematics solvers and paste into your folder. There's gonna be this one. Okay, so now let's copy. Okay, These are copy. Of course, we need to adjust a little bit because we need to check if we don't have any Panda configurations. So here we need to type the finger right joint. I can understand that it's not easy for you to understand out of the box because you don't have the background of the URDF file that I have created. But if you follow the masterclass, then everything will be much cleaner. Then let's have a look in this. So we didn't change nothing. So this is the planning algorithm that we might use. So here we are. If you scroll down, you need to change Panda arm to the name of the group that you have set up in the MoveIt setup assistant. Then the hand, it's gonna be a gripper. Let's save it, and then basically nothing else changed. Okay, so we have updated our configuration folder. Okay, so another important thing that I wanted to point out is the following. If you go in your ARM MoveIt configuration package and we go in the demo launch file, what we are gonna see, you're gonna see that the demo launch file is gonna be very easy, okay? And as I told you, in MoveIt2, you need to provide the controller manager node by yourself. You're gonna be explicit on the controllers that you are gonna use, okay? And so another important thing is that if you compare also the launch file that we have just started before, you are gonna see that this demo launch file is gonna be really much more complex than the one that we have set up it here. So what we're gonna do now is to create a new demo launch file that spawns the controller as well. Demo with controllers. Launch.py. Okay, so allow me to copy and paste from another package, and I'm gonna explain you what I'm gonna do. Okay, there we go. So here we have imported our library. This is a normal structure of a launch file. It's very similar to the launch file where we have spawned our robot in Gazebo. But basically the main difference is that the robot description that we need to spawn our robot in the scene is gonna pass through the MoveIt configuration object that is in an instance of the MoveIt config builder. So this is an instantiation of the MoveIt configuration builder where we passed inside the package that we have created the custom robot URDF chakra file that has been automatically generated. Then we pass the semantic description and the MoveIt controllers, and with the pipelines for the planning that we have just imported. Then we need to set up the pathway for our ROS2 controller. There we go, here, that is going to be automatically generated. Okay. Then here an important thing. Here we create a node using the controller manager package with the executable ROS2 controller node, and we pass as a parameter the robot description that is configured in the MoveIt config. Okay. Then here we need to spawn the joint state broadcaster. Then we need to spawn our ARM controller spawner that is referring as an argument the ARM trajectory controller. And again, here let's put it side by side. And we are gonna do the same for the gripper controller spawner, and is gonna be this one. So make sure that this name is exactly the same of this and this. And then if you work with MoveIt, you need to activate the move group node. Then we pass the MoveIt RVs configuration that has been automatically generated. And then here we need to open the node RVs. Okay. And then most important thing is the robot state publisher. And then basically you return all the node that you have just created. So if you are going to test it out, it's not gonna work. Why that? And pay attention, because this is really tricky. When you load it, you're gonna load the robot description. And the robot description parameter that is passed these files, okay? So this files is going to be this one that is automatically generated from our MoveIt configuration package. Here, in this file automatically generated, we are including this chakra file, that one that we have used in our gazebo simulation, which is this one. Then if you scroll down, it's gonna use this ROS2 tag that has this hardware interface, gazebo ROS2 control. And after that, it's gonna load this file that is loading a custom robot ROS2 control macro that contains, if we go here, another hardware interface that is going to be mock components. So there's going to be some confusion, because if we load this file, we are going to load the hardware this hardware interface, the gazebo ROS2 control. But then we're going to use this macro that is faking the controllers with the mock components hardware interface, this one. Okay. So this is the reason why is not working. What we can do here is, for example, if we wanted to run into a gazebo, into a simulation, we need to choose which kind of hardware interface we wanted to spawn. Okay, for example, don't use this one, and if I wanted to make it clean, just create a property here that is going to be gazebo control. There we go. And here we can add an if statement like this, and we close the if statement here at the end of the ROS2 control tag. There we go. So, since that we set up here as default false, then if we go here, not this one, we are gonna load this file, but since that is gonna be false, we skip everything here, and we're going to use the mock components that belongs to this macro. Okay, so let's let's build the package and try it out. Okay, so let's close this one. We don't need this anymore. We are not going to use this, so we are trying to launch this file. So ros2, then launch, then the name of the package is going to be arm MoveIt config, and then this time we are going to launch the demo with controllers launch. Let's see what's happened. Okay, here there's gonna be a good sign because the gripper action controller has been spawned correctly with the ARM trajectory controller and the joint state broadcaster. Okay, so now let's try to move our end effector, for example, to the home position. And then this time, there we go. So it's planning and it's executing the command now. So it's not failing anymore. There we go, it's executed. Let's check if the gripper went okay. There we go, it is executed. There we go. And let's get some fun here and move, I don't know, whatever you want. There we go. Okay, so that's all for today. I hope that you enjoyed this video and you got a lot of added value, and it solves the problem that you have faced in interfacing MoveIt and your ROS2 package. Again, here I understand that this tutorial could be complex because it's gonna start from an intermediate level, but I want to let you know that if you want to follow a structured journey in let you becoming a robotic software engineer, you can check this masterclass. I'm gonna put the link in the description down below, where I'm gonna teach you step by step, even if you don't have any background in robotics and ROS in particular, how to deploy a real industrial robotic application like a pick and place application with the camera. So we are gonna use ROS1, ROS2, MoveIt1, MoveIt2. We are gonna simulate our environment in Gazebo, and we are gonna use two different tools for computer vision like OpenCV and Point Cloud Library for 2D and 3D respectively. So have a look in the curricular. It's gonna be a structured pathway that will transform you from zero to a senior robotic application in round about 3 up to 4 months, depending on the time that you can spend in it, that you can invest. The course is under constructor, so you can benefit a 75% off discount, and I'm gonna put the code, the coupon code in the description down below. If you like this video, make sure to subscribe to the channel, and that allows me to take the time to build hopefully useful tutorial for your robotic application. And as always, keep learning robotics with ROS.